Hello AP Calculus, we got a new video. It's the second lesson of section 3.4, still going out of our textbook on page, in this case, 126. So we got something totally new to look at. I will be here to guide you. So the directions on number 29 state, find the equations of the tangent line and the normal line, that might be new for you guys, to the graph f at the point pi over 4, f pi over 4. So, translation, we're going to have two linear equations here. One's going to be pretty standard. The whole tangent line thing's pretty easy. So let's do that first. All right? How do you find the equation of a tangent line? Let's make sure we got that. Okay. Step one. We need the m of the tangent line, which we know to be the derivative at the point in question. So, f prime at pi over 4, we can take the derivative of secant. The derivative of secant of x is secant of x tangent of x. I don't have my list over here. I just trust that you guys have it written on your notes and you're referencing it quite frequently. Pi over 4 goes in for the x value here. This is going to be the derivative. This is what m equals. So then if you think about the unit circle, pi over 4 for tangent is just the 1 value. Right? Opposite over adjacent for a 45-degree angle is always going to be 1. Secant, think about cosine. Cosine is root 2 over 2. Flip it, you get 2 over root 2, but that's the same thing as 2 root 2 over 2. It's just root 2. Okay, so the slope of my tangent line is equal to root 2. Got my first piece of info. Step 2, I have x, pi over 4. I need to find y. So plug secant of pi over 4. Well, we already know what that is. It's root 2. And then our m we know is also root 2. So at this point, we can plug those values into y equals mx plus b. Root 2 equals root 2 times pi over 4, kind of an awkward value there, plus b. So this is root 2 equals root 2 over 4 times pi plus b. So I subtract this value from both sides. And okay, this is kind of interesting. You can factor a root 2 out. I've seen this done quite frequently, where they say, hey, this is root 2 times 1 minus 1/4 pi, or pi over 4. And they say, that's our b value. I don't know if you necessarily need to do that, but that's a way of simplifying. So y equals root 2x plus that. So there's the equation of my tangent line. Let's double check. I've been making some mistake on these videos, so they wrote it quite oddly. But that's the same thing. Okay? Got it. Tangent line, check it off the list. Now what about the normal line? Well, if you've not done a Google search of what is a normal line yet, the normal line is the line that is perpendicular to the tangent. the normal line is perpendicular to the tangent line, and that's all I got to say. So with perpendicular lines, you know that the slopes are negative reciprocals. So if m tan equals root 2, then m normal, the slope of the normal line, or the line that's perpendicular to that, is going to be flipped and made opposite positive. So we found our slope right away. And we know what our xy's are. X is still equaling pi over 4. Y still equals root 2. M equals negative 1 over root 2. So we're going to get a similar weird equation out of this. Root 2 equals negative 1 over root 2 times pi over 4 plus b. And I guess we can multiply both the top and bottom by root 2. This would make 8 on the bottom. If I added this to both sides, I get this. And you know what? I'm just going to leave it like that. Y equals negative 1 over root 2x plus this. So there's my normal line. Check out 31 now. They give you a graph of a trig function in which they've restricted the domain to just 0 to 2 pi. And they're asking you how many horizontal tangent lines are there. So first of all, the way we think about this is horizontal lines have 0 slope. So they're essentially asking us to say, hey, where does m tan equal 0? Where does the slope of my tangent line So we got to take the derivative of this function, set it equal to 0, and then find our solutions that exist between 0 and 2 pi, including both of those bounds. Now looking at the graph, you notice that it has a peak and a valley. Probably means that there's only going to be 2 solutions where the horizontal line, how should I say this? There's only 2 horizontal tangent lines in this window. So my derivative, the derivative of cosine is negative sine. The derivative of sine is just positive cosine. I'm going to rearrange them and then set this equal to 0. Okay, so I've got 2 options here. My 2 options are, 1, I can be a little more analytical with this. What I mean by that is, let's say that I move the sine of x to the left-hand side. Add sine of x, add sine of x. I could just ask myself, hey, where does the sine of x equal the cosine of x? And then just think through it using the unit circle. So hopefully you guys are thinking about pi over 4s. right? Because at pi over 4, you got root 2 over 2 for your x and root 2 over 2. You've got root 2 over 2 for your x. You've got root 2 over 2 for your y. So at here, we've got root 2 over 2, comma, root 2 over 2. Does sine equal cosine here? Yes, it does. X equals pi over 4 then is one of the spots where sine equals cosine. So that is a solution to the equation. Here, you got negative root 2 over 2, positive root 2 over 2. Does sine equal cosine? No. So 3 pi over 4 is not a solution. Down here, does negative root 2 over 2 equal negative root 2 over 2? Yes. So 5 pi over 4 is another solution to this equation. X equals 5 pi over 4. And then you'll find that in quadrant 4, it doesn't work because one's positive root 2 over 2, the other's negative. So at x equals pi over 4, 5 pi over 4, we have horizontal tangent lines. And they actually want the points at which you make that, the points that make the horizontal tangent line, find the points. So you'd have to plug the pi over 4 back into the original equation to figure out what the other ordered pairs are. So pi over 4, comma, root 2 over 2 plus root 2 over 2. All right, there's two of them. 2 root 2 over 2. So it's just root 2. And then with 5 pi over 4, that's literally just going to be negative root 2 over 2 plus negative root 2 over 2, which gives the same thing here, except you got negative. So I don't know if that makes sense to you guys, but there is another way to do it. You can think in terms of when we were trying to solve trig equations back in pre-calc and say, hey, you know, I can square both sides of the equations, create pi identities, and then hopefully from there find a solution. So again, I can move the sign to the left-hand side, square both sides, move the sign squared back, and there's actually a double angle formula if you look on your sheet that says that the cosine of 2x equals cosine squared x minus sine squared x. Seems like that would be the most efficient way to end this equation. Because what you would do is you'd ask yourself, where are the places where the cosine function equals 0 on the unit circle? Cosine is the x value, so you're not moving right or left, so at pi over 2 and 3 pi over 2. But then you got to read, there's double the number of solutions because it's 2x. So pi over 2, 3 pi over 2, then 5 pi over 2, sorry, and then 7 pi over 2. And what would normally equal x now equals 2x. So divide everybody by 2. You're left with all the pi over 4s on the grid. And then what you got to do is, since you squared both sides, you have to check all your solutions, because squaring something fundamentally changes what that equation was to begin with. So the 3 pi over 4 and the 7 pi over 4 end up being extraneous solutions, and you're left with pi over 4 and 5 pi over 4 to get these same answers using the same process of plugging back into the original. As you can see, the red is a lot more work, but it's what you guys know to do from pre-calculus. The other way, more efficient, but you gotta be able to work with those kind of wishy-washy informal techniques. So I'm letting you choose which technique you use. All right, that seems like a good stopping point. Another video coming up soon.